All right, guys, we're on day 3 of Unit 8, and this is right triangle proportions with altitude. Okay, so our warm-up, it says line L is mapped onto line M by a dilation centered at the origin with a scale factor of 2. And the equation of your line is 3x minus y equals 4, and we're going to determine and state an equation for line M. And so we have to realize, guys, that we're just dilating a line. And so remember that a line is made up of 2 parts, M, which is our slope, B, which is our y-intercept. Because dilated lines will always be parallel, they have to have the same slope. Y-intercept is a point on the y-axis, and points get multiplied by the scale factor, so we have to remember to multiply by scale factor. Problem is, this line isn't in y equals form, so we can't tell the slope in the y-intercept yet, so we're going to go ahead and rearrange it. So it's up to you how you want to rearrange it. There's 2 ways. You can subtract 3x and then divide by -1, or you can add y to the other side and then bring the 4 back. All right, I think you guys have better luck with doing that second option. Okay, so I'm going to go ahead and add y to this side. And so I'm going to end up with 3x equals 4 plus y. And then I'm going to subtract the 4 back over. And we're going to end up with 3x minus 4 equals y. And now I can tell you guys that 3 is my slope. And that -4 is my y-intercept. And now I'm going to go ahead and follow the rules that we talked about over here. And my new equation of my line for line M is y equals, we said that the slope must stay the same, and our slope is 3. So we're going to keep it the same. Slope is always followed by the x, so the 3x becomes part of our equation. The y-intercept is -4, and we have to multiply that by our scale factor. What is our scale factor? It's 2. So if we take our y-intercept and we multiply him by 2, that's going to turn into a -8. And there's the equation of our line. Okay. All right, going down. We have theorems here. All right, and we have to know these. It says when an altitude is drawn to the hypotenuse of a right triangle. All right, so what happens here in this picture, just so you guys can see, normally right triangles to me should always be drawn like this. Okay, that's how the way we're used to seeing them. In that right triangle, this is a leg and this is a leg. And since there's 2 of them, they will usually put a little 1 here and a little 2 as the subscripts to denote which one they're talking about. This here is my hypotenuse. All right, but in most of these problems, the little right triangle here kind of gets tipped over. All right, so it's like a big pulley comes and pushes the right triangle over. All right, and when that happens, the right angle is now up in the air. All right, so now the right angle is up here. This is still my leg. If you think about this triangle here being pushed, this would actually be my, it actually doesn't really matter. So we can call that still leg 1, and this is leg 2, and this will be my hypotenuse. All right, what happens next is they draw in an altitude. Altitude is another word for height, and height has to be perpendicular. So when they draw it in from the right angle up here, it has to go straight down. And when it goes straight down, because it's going straight down, meaning perpendicular, it forms right angles down there. Okay, and this is my altitude, ALT. Okay, what happens next is that when that altitude's drawn in, it forms a point on your hypotenuse, and it forms a little line segment here on the left-hand side, and it forms another line segment over here on the right-hand side. Okay, they call those segments here projections. Okay, this is a projection and this is a projection. Okay, because there's 2 of them, they usually use those little numbers to denote them. All right, and you're going to see that because this is called leg 1, this is why they call that projection 1. Leg 2, projection 2. All right, so the 1s happen on the left-hand side of the altitude, the 2s happen on the right-hand side of the altitude. Okay, all right, so what happens is that when that altitude is drawn in, it forms a couple triangles. Okay, obviously we have the original triangle that we had, the original right triangle, but then there's this right triangle now. Okay, and then there's also this right triangle. Okay, and obviously the whole right triangle. All right, so the blue one, the red one, and the green one are all right triangles. They also have a second angle in them that is equal to the angle in all 3 triangles, and so the 2 triangles end up being similar to the original and similar to each other. Okay, so it says the 2 triangles formed are similar, okay, to the original triangle and similar to each other. All right, so because they're similar, Then we can set up proportions with their corresponding sides and solve for anything that's missing. But because the triangles kind of have been turned and flipped, it's very difficult to see what matches with what. And therefore, they made our proportion almost like a formula to plug into to make it easier for us. Okay, in this proportion, it deals with 3 pieces. It deals with one of the projections over the altitude, and then the altitude over the projection. So we come up with a little saying to help you remember that, and we use the P, the A, and the P to help us remember. And our saying is pigs are awesome pets. And so when we know we're using the altitude in our problem, our proportion, we automatically think pigs are awesome pets. And so we write pigs are awesome pets. And we just have to remember one little thing is that the P's are different. All right. One's a 1 and one's a 2. However, we only have one altitude in our picture. And so the A doesn't need any little numbers on it. It's the same exact thing that you plug in for both A's. Okay. So let's see how this goes. So in number 1, it says that if JH equals 8, and JL equals 20. Now, I totally recommend a bracket there. And they want you to find KH. All right. So what we have to realize is that this here is our altitude. Okay. This 8 here is our projection 1. Okay. And this 20 is our hypotenuse. It's what the triangle fell on when he got pushed over. All right. So anytime you have an altitude, you always go with pigs are awesome pets. Just got to remember that this is projection 1 and this is projection 2. Okay, so we got to look at our picture and say, do we have all those pieces? Yeah, of course, we have the altitude. Okay, we have projection 1, but we don't have projection 2. Okay, and therefore we have to do a little subtraction here. If we know the whole hypotenuse is 20 and the 20 is made up of 2 projection and one is 8, you're going to go ahead and do a little math and figure out that this one is 12. And that right there is our projection 2. Okay, and now we're just going to plug in our pieces. So we go and say, all right, who's projection 1? Our projection 1 is 8. Our altitude is what we're solving for, which is x, equal to the same altitude of x over our second projection, which is 12. And now all we have to do is cross multiply. X times x is x squared, equal to 8 times 12, which is 96. We take the square root, and we end up with x equals. Now, 96 isn't perfect, and the directions don't say simplest radical, but we're going to do it anyway since that's what we've been practicing. Okay. The largest perfect that goes into 96. All right. You might need your list of numbers. Okay. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. All right. But the largest perfect that goes into 96 is 16. So 16 gets the first house, 16 goes in 6 times, okay? And the square root of 16 becomes 4. And so we end up with x equaling 4 square root of 6. In simplest radical form is the length of our altitude, okay? Or we could have also said KH equals 4 square root of 6. Either one doesn't matter, okay? And there's our answer. All right, I will see you guys on the back side of notes.